Hi there, gang. And in this section, we're going to study a very, very important function known as the exponential function. And this is a function that you've probably heard of before. You've heard people probably say things like something grows exponentially. And it's a function that has lots of applications that we'll look at in the following section. So first of all, let's define what we mean by an exponential function. So an exponential function is of the form f of x equals b to the x, where b is some constant, and the constant has to be greater than 0, and it can't equal 1. So the two main examples, helpful examples, suppose we talk about y is equal to 2 to the x, and think about the graph. When x is 0, 2 to the 0 is 1. As x gets bigger and bigger and bigger, 2 to the x gets huge, fast. When x gets very negative, think about like 2 to the minus 10. That means 1 over 2 to the 10, which is very small, but greater than 0. So what we do is we get close here, and this is an asymptote. So the domain is all reals, and the range is y greater than 0. And the y-intercept is 1. Now, contrast that, say, with one that looks like this. 1/3. 1/3 raised to the x. Now, when x gets big, well, first of all, if x is 0, we're still going to get 1. But when x gets big, 1/3 to the 5, 1/3 to the 10 means 1 over 3 to the 10. So in this case, we get asymptotic in that direction. And how about 1/3 to the minus 5? That means 1 over 1/3 to the 5, which is the same as 3 to the 5. So in that case, it gets big in this direction. It's kind of flipped over the y-axis. But domain is still all reals, and the range is still y greater than 0. Right? So those are two examples. This is where the base is bigger than 1, and this is where the base is between 0 and 1. And they both have those kind of characteristic shapes. So let's use this as an example to do our work with graphing transformations. The basic graph here, kind of the what's sometimes called the parent graph, is y is equal to 2 to the x. But it gets moved a little bit here. So instead of x, we have x plus 3. Now you should remember that that moves the graph 3 to the left. And instead of, well, not instead, but then we have minus 4, and that brings the graph down 4. So one of the things that means is that instead of the horizontal asymptote being the x-axis, it's actually going to be down 4 units, like so. So this is the line y equals minus 4. When x is 0, what do we get? When x is 0, we get 2 to the 3, that's 2 cubed, 8, minus 4. Okay? Now, how about the x-intercept? The x-intercept means set y equal to 0. So we have 0 is equal to 2 to the x plus 3 minus 4, which is the same thing as saying 2 to the x plus 3 is equal to 4, which is the same as 2 squared. So we're kind of getting into solving exponential equations. And the only way that this can be true is if this is equal to that. So that means x plus 3 is equal to 2, or x is equal to minus 1. So that's the x-intercept, minus 1. The y-intercept we already saw is 4, so the graph looks something like this. Okay, so there's lots of work that you'll be doing with graphing of exponential functions. And that's an example, a simple example of how you graph them. So let's look at solving equations involving exponential functions. All right, so we want to solve for x here, and this is very similar to the one that we just did. So we simply write this as 2 to the 3x minus 1 is equal to 8, which is 2 cubed. And the only way that can be true is if 3x minus 1 is equal to 3, and that means x is equal to 4/3. Okay? So that's pretty simple. Let's step it up one level of difficulty. Okay, so check this one out. Looks kind of weird, and what makes this problem doable is that both 4 and 8 can be written as powers of 2. So instead of 4, I write 2 squared to the x minus 3. Instead of 8, I write 2 cubed. So now if I write these each as a power of 2, using my rules of exponents, I multiply here. So this gives me 2 to the 2x minus 6, and this is the same as 2 to the minus 3. So what that means then is that 2x minus 6 is equal to minus 3. So if I add 6 to both sides and divide by 2, I get x is equal to 3/2. So that's how we solve these exponential equations, and what made them both nice is that we have the same base. Each of these numbers can be written as a power of 2, and each of these could be written as a power of 2. Okay, doke. See you next time.